Why does cone volume use a circular base? Have you ever wondered why the volume of a cone relies on a circular base? It's a fascinating question that reveals a lot about the shape and its properties. Let's break it down together. A cone is a three-dimensional shape that starts from a flat, circular base and tapers smoothly to a single point called the apex or vertex. The circular base is key because it provides a stable and symmetrical foundation. This symmetry allows the cone to look the same when rotated around its central axis. Now, when we talk about the volume of a cone, we use the formula volume equals 1/3 times pi times radius squared times height. Here, the base being circular is essential because the area of the base is calculated using the formula for the area of a circle, which is pi times radius squared. Interestingly, the volume of a cone is 1/3 the volume of a cylinder that has the same circular base and height. This relationship comes from how the cone narrows from the base to the apex, reducing the space inside compared to that of a cylinder. To put it simply, the circular base is used because the cone is formed by rotating a line segment around an axis, creating that circular base. Additionally, the base area must be a circle to use the volume formula effectively. The circular base also ensures that the cone has a smooth, continuous surface that tapers to a point. Understanding the circular base helps us grasp other important properties of cones. For example, the height is the straight line distance from the base to the apex, while the slant height is the distance from the edge of the base to the apex along the curved surface. These two measurements relate through the Pythagorean theorem, which is a fundamental concept in geometry. In real life, we see cones with circular bases in many everyday objects. Think about ice cream cones, traffic cones, and funnels. The circular base provides stability and a consistent shape, making volume calculations straightforward. So, the use of a circular base is not just a random choice. It is fundamental to the geometric definition of a cone, its symmetry, and the way we calculate its volume based on the area of that base combined with its height. Understanding this concept opens the door to a clearer view of three-dimensional shapes and their volumes.